Okay, so this is 10A, Introduction to Java Programming. As I've already said, my name is Dave Wisniewski. Just call me Dave. And, you know, to the people that are in the classroom here, I've already kind of given you some of these tips. One is, you know, the course goes very quickly this summer, so, you know, don't fall behind. You know, do get a copy of the book. And in addition to what I'm saying in lectures here, you'll find that you probably learn the material a lot better if you come to class, listen to what's going on here, ask questions, but then also go home and review the material that we're covering in the book and take a look at the questions that are at the end of each chapter that I assign. Okay? Ask questions in class or email me if you know, if there's something you don't understand or you're having difficulties in class or can't attend class. Okay. Programming is a lot of problem solving. Okay. So it's going to require thinking. So don't expect every assignment, you know, you just read the assignment and, oh, you know, the solution is going to instantly be obvious. Some of this stuff does take some thinking. Okay. So again, you know, think for a while. Talk to your colleagues, your peers, people sitting next to you. You know, ask for hints and help from me. Okay, but first of all, try to solve the problems on your own if you can. Okay, and avoid just, you know, copying somebody else's solution without understanding what you're doing. And, you know, the way to learn programming is to do lots of programming. So hopefully we will be doing that in the next 8 weeks, and we will have some fun assignments as well. Okay. So we're going to be learning Java. Java is a programming language. So the language is essentially a tool that we use to tell the computer what we want it to do. Okay. There are many different languages out there. Java is just one. As I said, when I first started learning programming, we learned in Java wasn't around then, so we learned in Fortran. The other word that you'll hear come up a lot is called a compiler or compile, and so a compiler is something that when we program in a high-level programming language that's easier for humans to understand. Okay, but it's not a language that the hardware of the machine can understand. So we use a software tool called a compiler that translates the code from our program, and we're going to be writing in Java. Yes, I see that doesn't look too well. I've got to resync my board. Okay, let's see. Java. All right. And we're going to be going into machine language. Okay. Later on this week, probably Wednesday or Thursday, we'll talk a little bit about you know, machine language and how this compilation process works. Okay. Java actually uses a two-step process. So in the first step, the compiler is going to be taking our source code, and source code we put out, and there's a convention in Java that the file name ends in .java. Okay, so if you go out with Windows Explorer and you look at the directories where we are working in, okay, you'll see files out there that end in .java. So those are your source files. Okay? And you can edit those. We'll be using an editor called BlueJ, but it turns out you can edit those files with any, you know, text editor. You can use, you know, Notepad or WordPad or anything like that. They're just a source code file. And you'll also see some other files out there that end in .class. So for every program that you write, you're actually going to see two files. So if I write a program called program1, you'll see program1.java and program1.class. Okay. The .java is the source code that you wrote, that you typed into the computer. and the .class file is the compiled code that contains the instructions for the hardware of the machine. Okay. And Java uses a process. It's actually a two-step process. There's a compiler, and then there is a Java runtime environment. Okay. And so in order to develop a Java program, which is what we're going to be doing, you need to have both the compiler and the runtime environment. And both of those are combined together in the Java development kit. And so if you download at home, if you download the JDK, Java Development Kit, you'll have both of those. If you're setting up a computer for a non-programmer, and that person wants to be able to run Java programs, but they're not a programmer, they're not going to be writing Java programs. They want to run Java programs that someone else has written. Then they only need the JRE. Okay, so the JRE is the runtime environment. And if you're on Windows, Windows includes, if you just install the base Windows operating system, it actually includes a JRE in it. Okay? I don't know if it's the most current version of JRE. It usually wasn't, but it's there. If you're on some non-Windows system, then usually you have to go and get the JRE and install that as a separate process. Okay, Java is a programming language that is also called an object-oriented programming language. And what that means is a couple of things. One, large programs in Java are broken down into smaller things called classes. Okay? And for at least starting off in this class, or I should say this course, otherwise I'm using the word class to mean two different things, okay? So at the beginning part of this course, the programs we'll be writing in Java will basically consist of a single class, one class. Okay? And then as weeks go on, we'll start to write more complicated things that use multiple classes. So every class has to have a name, okay? And we'll see some examples of classes in a minute, and they have a name. Every class consists of one or more methods, and in the methods are essentially the instructions that make up your program. Okay? And in addition to the instructions, there's also names of objects called variables. Okay? So these hold the data that your methods are going to use, and we'll take a look at some examples in a minute. Now, real-world programs typically have hundreds, thousands, I mean, they might even have tens of thousands of classes. Okay, so just to give you an idea of what really big programs look like. Another word that programmers talk about, and as you browse through Chapter 1, you'll see that, and that's this acronym here called IDE. Okay. And IDE stands for Interactive Development Environment. Okay. So the thing that we'll be using in this class is called BlueJ. BlueJ is an example of an interactive development environment. It essentially includes it takes the compiler, and it takes the editor, and it takes something called a debugger, which programmers use, and it kind of combines that into one nice window interface. So you can compile things, you can edit things, compile things, and debug things rather quickly. And we'll be getting. I'll show you how to use BlueJ in a little bit. Okay. And the last thing is that in addition to the Java language, okay, we're going to make use of a lot of software libraries. So there's two kinds of software libraries. There's libraries that come with Java. So when you download and install the Java development kit, you get a whole bunch of libraries that come with Java. These libraries let you do a lot of things like graphics, and reading and writing to the internet, reading and writing to disk files on the hard disk. In addition, oftentimes if you download other Java programs written by other developers, or if you go out and buy commercial programs that are written in Java, they will come with additional software libraries. Okay. And we'll show you in this course how to use the Java import and inheritance capabilities to make use of the software libraries. Okay. All right. Why don't we take a how to use BlueJ? So to do that, on your machine, you want to go and probably the easiest way to do it is just type in the word BlueJ into the search bar, and it should bring up. You'll see two things. One is BlueJ, and select BlueJ VM. So you just want to click on the item that says BlueJ. And that should bring you up a window that looks like this. Okay, so this is the project window in BlueJ. And the first thing you have to do is to create what's called a project. Now what a project does is it actually just goes out and it creates a folder or a directory out on your hard disk. So under the project menu, you would say new project. And then you have to decide where do you want to put this project. So the best place to put it is if you have a flash drive, put it on your flash drive. That way it'll get saved out there. Those of you that logged on with a 10A user ID, 10A01 to 10A029, you probably should see here what's called the U drive. Okay, a drive with the letter U. Okay, that's your personal network drive here for the 10A class. Okay. So if you don't want to put if you don't have a flash drive, then you can put it out on the U drive. Now, you can also put it on the C drive. That's where I'm going to put mine. But remember that next time you come to class, other students can sit at this machine. They may delete stuff. The machine might crash. They may re-image it. So anything that goes on the C drive may not be there. The next time that you come in. So I'm going to create a folder called temp, and I'm just going to call this project 1. Okay. Give it a name to your project, and then you say create. Okay. So now you have a project, and the name of the project appears up there. So is everybody with me so far on that? You've been able to start BlueJ from the start menu. You get a project window and you've created a project. Okay. Anybody having any difficulty? Okay. If you are, raise your hand, because you've got to have a project created before we can go on to the next step. Okay. Now, as I said before, in Java, Java is an object-oriented programming language. Everything in Java belongs to some class. Okay? Unlike some programming languages, you can just program without putting stuff in a class, but Java requires everything to be in a class. So we're going to create a class. So you can either hit this button here, or you can just do a right mouse click over on the empty window here, and you can say new class, and again, you give it a class name. So I will call it demo, a demo class. So if I were to go out to the hard disk right now and look there, I would see a folder there called Project 1. That's the name of the directory. And inside there I would see a demo.java file, which is my demo class. Yes, question?
Should I get my number for username, or should I look that way after?
Oh, okay, yes. Okay, so let me, I don't need to be recording this part here. Okay, so we've created a project, we've created a class. Now, if you go in and you either double click on demo, or you can do a right mouse button and you can say open the editor. Okay, it will allow you to edit that class. So you're looking at the source code for the class here. Now, what BlueJ does is it kind of gives you a template for your class. Okay, so, and the template that it gives you is not particularly useful. So the first thing I'm going to do is I'm going to go in here and I'm going to highlight all this text and backspace delete it. Okay. So I'm going to start off with just a completely empty class. Okay. And every class in Java has to start off with a class header, which starts off with the keywords public class and then the name of the class. So remember, I called my class demo. So if you called yours something different, well, then make sure you change the name, okay? So this is called a class header. And the open brace and the close brace, this is the beginning and end of the class. So right now we have a class that doesn't have anything in it. All it is just a class header. Okay, the next thing we're going to do is we're going to create a method, because I said a class consists of variables and a method. So we're going to have a method, and in Java programs you're required to have what's called a main method. So what the main method looks like is you say public static void main. All right. So this is a main method header. How come it's not writing? Well, this is one of these things. Learning to do this well, how come it doesn't let me write? Because it's taking it as input. All right, let me try this. All right, class header. That's what I wanted to write. But every time I would write on the board, it was thinking it was a mouse input. Okay, so that's class header. So now we've created the class header, we've created the method header. Now, as the course goes through, we're going to explain, what all these different keywords like public, static, void, string with braces, what all those things mean, okay? But just to get started for today, you just have to accept that those things are required in the class header and the method header. And so I'm going to write a line of code, and I'm going to tell it to print out the words. Okay? And the way you tell Java to print something out is with the statement system out print line. System out, PRINTLN, and parenthesis, and then in quotes you can say whatever your message is. All right. So when this program runs, the instruction is just print out the words hello world. So hello world has to be in double quotes. Okay. Within the double quotes you can put any message you want, but just make sure that it begins with a double quote, ends with a double quote. Now see if the program is a valid program. You can hit the compile button up here, and it's been compiled, and you should get the message down here. Class compiled, no syntax errors. So, if you get something else, if you get some kind of error, then you want to go back and double check your typing. Make sure you spell all of the special keywords correctly. All right. So any questions on that? Entering in the code, the class header, the method header, a line of code that says system out, print line hello world. And then to run it, we can close the editor, and then we'll go back to the project window. Notice the icon here has changed. So that means that before it had hash marks on it. So that means that the class was not compiled. Now it means the class is compiled, and we can go and we can run the main method. So we right mouse click on the icon, and it will list what we can do. We can edit it, we can compile it, we can also run the main method. So I'm going to run the main method, and it says, do you have any arguments for the main method? No, I don't. Just hit OK. Okay. And then in BlueJ, a window called the terminal window comes up, and there's the message that I wanted to be printed out. Hello world. Okay. So, is everybody okay with that? Anybody not able to get their program to compile or run? Okay, so some of the problems that people were having was Java is very case sensitive. So there's a difference in Java between public spelled with a capital P and public spelled with a lowercase p. So the key word in Java is public with a lowercase p. Okay. Same thing with class. There's a difference in Java between parentheses and the braces. Okay, the curly braces and things like that. So every line of code in Java ends in a semicolon. Okay, so a common mistake is I forget to put in the semicolon sometimes, or sometimes you put a colon in instead of semicolon. So Java is very picky about these things. And system has to be a capital S. If you type in lowercase s, it'll say system does not exist, because system with a lowercase s and system with a capital S are considered two different words in Java. Names of methods like print line, you have to spell it exactly the way it is with lowercase letters. So once you have something that runs, you want to save this. Okay, because this is your template. Whenever you have to create a class and a method, you now have something that works, and you can just cut and paste this and then modify it from there. Okay, so it's a good idea to always, start with some example that works, either out of your textbook or now you have a small working program. Okay. All right, the next thing we're going to do is we're going to do a little bit of a string manipulation. Like, for instance, here I'm just printing out a single message, hello world, but I can also do it like this. I can say print hello and concatenate it with world. Okay, so that's going to print out hello world, but it's going to put the two together. Okay, so the plus sign will take two different strings and put them together and then print them out. Okay, so if I make that change and compile it and then run my program. Okay. So on my terminal window, the terminal window saves all of your previous output. So this output here was from the first run I did. And then this is from the run that I just did right now. So if you want to get rid of all that, you can go up to the options window and say clear. Okay, so now you have a clear window. And then when you run your program, anything on the terminal window came from that run. So it's more obvious what your program actually did. Okay, so it took the two strings, concatenated them together. Maybe I want to put some space in there because I don't want the words to just run all together. So I could do something like this. Hello, space, concatenate that with space, world. So compile that and run that. And so that's a very simple program. It's just printing out one or two messages. How would you do this? Let's say you wanted hello to be on one line and world to be on the next line. Okay. What print line does, the command print line in Java, is every time you run print line, is it prints all of its message on a single line. Okay. So if I wanted this to be split into two lines, I could just do this with two commands, system out print line. Okay, so now it will say hello world, but the output, oops, got to spell it right. There. Now let me go back to the terminal window, let me clear it, and then run my program. All right, so hello comes out on line number 1, and world comes out on a line underneath it. Okay, so is everybody able to do something with print line and print a couple of messages out, either one line or two lines, or you make use of the plus symbol to concatenate different strings together? All right. Anybody have any questions? Because otherwise we're going to go on and we're going to look at variables and assignment statements and start doing some more complicated types of things. All right. Okay, when you're writing code in Java, sometimes you want to write things not for the computer, but either for yourself or for other programmers. Okay, these things in source code are called comments. Okay? And so here's an example of a program that has different comments in it. So a comment in Java, this, when you have two slashes in a row, that marks the beginning of a comment. So everything from the double slashes over to the right is all a comment. Okay? Here's another example of a comment. Okay? So here's a system out print line. So that's a Java command, but all of this is just a comment over here. Here's a comment. And even though it looks like a line of Java code. It says system out print line hello world, but it starts with a slash slash, so that makes it a comment. So that's one style of comment. And the other type is this type up here. You can start the comment with a slash and an asterisk, and you can go across multiple lines, and it continues the comment, and you finally end the comment with a asterisk and a slash. And if you accidentally forget that ending asterisk slash, then your whole program just becomes a comment. Okay, so which is probably not what you want. So you got to make sure that you begin the comment up here and that you end the comment. Okay. The double slash, when you get to the end of the line over here, that will terminate the comment for you. Okay. Oops. Okay, comments, okay. We saw an example of print ln, which means print line. So take the message there and put it on a separate line of code. But there's also a command in Java called system out print. Okay. And let's just type in that code there to see what it does. So I'm going to go back to BlueJ. Yes, I'm going to go back to BlueJ. Back to my program. And I'm going to do a system out print something, ABC, followed by print line hello world. So compile that. So I'm doing a print command followed by a print line command followed by another print line command. Compile that. Remember, each line of code has to end in a semicolon, so make sure you have 3 semicolons there. And let me go to my terminal window and clear that, so it'll be more obvious what my program's actually doing. Okay. So that's what, let me bring my program up. So there's my program, and there's what it printed out. So ABC, so the way this works is, here's my terminal window. No. How is this? How do I do this? I got to figure out how to use the smart board here. Notebook, recorder, keyboard, floating tools. All right, let's see whether this will work. Okay, so I'm going to have my terminal. Oh, this isn't going to work either. Oh. Well,
If you turn on floating tools, you should be able to switch between.
Floating tools?
Yeah.
All right. So floating tools.
And you'll see which one you've got chosen.
All right, yeah. But my problem is when I go to write there, it's interpreting it as a mouse input rather than as a. So how is that going to work? Well, all right. So I'm going to give up on the smartboard for the moment, and just explain what's going on here. Okay. So system out print. What that's going to do is here's my terminal window. All right. And when I do a system out print line, it takes the characters or the string that I'm printing and it puts it out there. So it's going to print out A, B, and C. Okay. But it doesn't put out what we call a new line character. It does not terminate the line. Okay. So what happens is when I do the system out print line, so I start off with ABC, okay? I don't end the first line, and then the next command comes out system out print line hello. And so hello is going to just keep going where it left off. Okay? So it's going to continue that line of output. Now the difference between print and print ln is when the print ln command works, it always terminates the line. So it's going to put a new line character here, which terminates the line. And then when the next command comes up, which is world, that's going to start on the new line. Okay. So the key difference there is print does not terminate the line that it's creating. Okay? And print ln, which stands for print line, prints its message, but also then terminates the line, and so subsequent commands will begin on the subsequent line. Okay. So in this example here, ABC and XYZ would all be on the same line. The second command here, print line, that's going to terminate the line, and so 1, 2, 3 appears on the subsequent line. Here's an example here. All these are using print line. So it prints out ABC, starts a new line. Then it prints out XYZ, starts a new line, prints out 1, 2, 3, and then starts a new line. Okay, so that's the difference between the print command and the print ln or print line command in Java. Now you can, if you want to, within your message or your string, you can also put a new line character, okay? And that is that's this character here, \n. Okay, so this is called the new line character. And when you type it on the keyboard, it's actually 2 characters. And when you display it, well, you won't actually see it because it's used by the display, but it doesn't actually print a character. So if I were to switch back to BlueJ, so I'm going to do my demo. Let's see, I'm going to print out 2 things. hello, and then I'm going to print out a new line, world. Okay. So what this is going to do is when it prints this message, when it goes to print the \n character, which is called a new line character, it will that will cause a new line to be started. So I'm going to compile this, and then I'm going to run my main program. And where is my terminal window? Here's my terminal window. Okay. So it printed this. Okay. So let me clear this and do it again, so it will be more obvious. Yeah. Okay. So if you want to print messages and have them appear on separate lines, you can either do it with separate print commands, or you can embed in your message, the \n character, okay, which is the new line character. All right. In Java, when you're handling data in your program, all data has to be, you have to be conscious about the type of data that it is. And in Java, there are primitive types, what we call the primitive types, and then there are class types. There's 8 primitive types. The ones we're going to talk about tonight are called integer, which is the keyword is int. So int is the keyword that you type in Java. But what an int is it's 0, 1, 2, -1, -2. So it's the integers that you used in arithmetic. Okay. Double numbers are the numbers that we used to call in algebra the real numbers. Okay, so they're numbers that have a decimal point and have something behind it. So real 12.5 would be a real number. Okay. Negative 3.6, 3.14, 159, which is pi. Okay. So those are all examples of real numbers. Okay. Java doesn't really have fraction. You can write a fraction with 2 divided by 3, okay? But double numbers are numbers that have a decimal point. You can also write scientific notation. So if I wanted to write 2 million, I would say 2.0 e to the 6th. So rather than saying 10 to the 6th, in Java the notation is e. E for exponent. Okay, e to 6. This would be equal to 2 times 10 to the 6th. So we have integers. We have real numbers. Booleans are data types that can only have 2 values. You either have true or you have false. Okay, that's the only data types Booleans can have. And character data types are a single character in Java. And so if you wanted to have the character A, you could type A, capital A, or lowercase a. Those are considered 2 different characters. Okay. And you put single quotes around a character value in Java. So those are considered the primitive types. There's 8 of them. There's a few others that we'll go through later on in the course. Okay, but this is enough to get us started. So we have integers, we have real numbers, which in Java are called doubles. We have booleans, we have characters, and then we have lots of other more complicated data types called class data types. Okay, so in Java, a string. So we were using strings when we did Hello World. So a string is multiple characters with double quotes around it. And we're going to look at some other ones tonight. System. So when you want to write things to the console, we were using system out print line. Okay. System is the name of a class. And later on, we'll get to classes like scanner that allow you to read things from the keyboard. Okay, variables in Java. So variable is it's a place in memory where you can store data. Okay, it's not a place out on the disk, it's a place in memory. And variables have, in Java, they're given names, and you have to have a data type. So if I wanted to have a variable where I could store an integer in, I would say int, and then I have to give it some name. I can make up the name. Just like I can name my classes and I can name my methods, I can give a variable a name. So I could call it A. So that statement there, int A, declares a variable. Its name is A, and it is of type integer. If I want to assign a value to it, then I could say A is equal to 10. Semicolon. Now I can't say 10.2 because 10.2 is not an integer. So the kind of value that you assign it has to be compatible with its data type. So if I try to do something like 3.14 equals A equals 3.14, then I'm going to get an error on that. The compiler won't let me do that. A couple of rules in Java. Well, okay, before I go that, let me talk about this. There's two ways I can do this. I can declare the variable, and then I can give it a value. I can also combine all those things in one line. By saying int A equals 10. Okay, so I can do that. There, I declare the variable, and I give it a value, all in one statement. But a couple of rules in Java is, before you use it, you have to declare it, and you have to give it a value. If I want to change the value of the variable, I can just assign it another number like this. So I declare a place in memory called A. It can hold an integer called 10. I can change it to 12. I could later change it to A plus 2. So what would that do? That would take the value that's stored in A, which is 12, add 2 to it, which would give 14, and then put it back in A. So right now, A has value 14 stored in it. Oops. Okay. So here's a small program that illustrates some of these concepts. Okay, so up here we're declaring. Oh, what happened to my slide? Okay, we're declaring a variable here. Okay, the name of the variable is letter, L-E-T-T-E-R. What's its data type? Data type is character, or char is the keyword in Java, char. The next line of code, okay, notice that a lot of these things are commented out. Okay, but here I'm declaring a variable, my integer. Its data type, it's an int, meaning an integer. It's going to be assigned the value 3. This line of code is putting the value A into letter. So if I looked at memory in Java, okay, I can think of, I have a place in memory called letter, okay, and I have a place in memory called my integer, okay, and this code up here, my integer equal to 3, that put the value 3 in it, and this code here, where it said letter equals A, put the character A into the place in memory called letter. So going down further in the program, then I'm declaring another variable called J. Okay. So how do I know that this is a declaration? Okay. So the thing that makes it a declaration is declarations always start with a data type. Okay. Starts with the keyword int, int, for integer, and then it's followed by the name of a variable. So that makes it a declaration. So I'm declaring a place in memory called J, and I'm giving it the value 5. And then I'm updating J. I'm saying J is equal to J minus my integer. So J is 5. My integer is 3. So it's going to do the subtraction there. Get 2 and replace going to replace J with 2. Oh, I shouldn't have erased my integer. My integer didn't change. That's still 3. Okay. So an equal sign in Java really means assignment. It's a little different than an equal sign in Java. I mean, in algebra. Okay. An equal sign in Java means an assignment. So you evaluate the expression on the right-hand side. You find out what the value of that expression is, and then you store that value into the variable on the left-hand side. Okay. Proceeding down in the program, I do a system out print line of J. That's going to display 2. I declare another variable, D. Put the value 3.7 in there. Okay. If I tried to do D is equal to my integer, so I would try to take the value 3.7 and put it into the variable called my integer. Okay, that's not going to work. And the reason that's not going to work is because my integer is declared as an integer. And it's an integer, okay, and I can't put 3.7 into an integer variable. Okay, so this line of code here won't work. But this one will work. Java does allow you to take integers and store them into real numbers. And it'll do an automatic conversion. So it's going to take 3 and put it into D. So it would essentially become 3.0. And then it will print out. Okay, so the important things on this slide is how do you declare a variable? Well, you specify the data type, and then you give it a name. You can assign things into the variable with an equal sign. You can change things that are there. You have to be aware of what the data types are. Okay. You can put integer values into double variables. Java will do a conversion, but you can't go the other way. You can't put things like strings or characters into integers and doubles also. Okay, so I think we've covered most of the stuff here. These are different data types. Integer, ints. Here's an example of an integer. There's another data type called long. So an integer in Java can hold any data type from, I think, like -2 to the 31 all the way up to plus 2 to the 31. So that's, if you work that out on a calculator, that would be like minus 2 billion to plus 2 billion. Okay. But an integer is limited. You can't put any number into an integer. If you need to deal with the national debt won't fit into an integer. Okay, so Java also has another data type called long. So it's sort of like an integer, except the range goes much higher. Okay, and in order to specify a long, you put an L on the end of the number. Okay. We talked about doubles and booleans and characters and strings.
How big is the range?
For long?
No, for int.
Well, I mean, it's approximately from -2 to the 31st power up to 2 to the 31st power. Okay? So in terms of decimal numbers, it's like 2 billion, minus 2 billion to plus 2 billion. So if you're dealing with, millions, you're okay. Okay, but if you get up beyond 2 billion, and if you want an exact number, okay, you don't want scientific notation. You want exact numbers. Then you have to use. You want to know the exact number?
No, I was just curious
Yeah.
about what the rough range was.
Okay, yeah, rough range, yeah. So. Arithmetic operations. Okay, so some of these you're probably familiar with, plus, minus. The asterisk means multiplication. So this is multiplication. The slash is divide. The percent sign means remainder. Okay, so if I do 5% sign 2, so that's going to be 5 divided by 2 is 2 with remainder 1. So this is going to give me 1. Okay. Java and many other programming languages have something called integer division. So if I'm dividing two double numbers, 3.0 divided by 2.0, that will give you probably what you expect it to be, 1.5, okay, 1.5. But if I do integer division, okay, Java throws away the remainder. So an integer 3 divided by integer 2 doesn't give 1.5, gives 1. Okay. So an integer divided by an integer is going to give you an integer. So it's going to throw away the remainder. If you don't want that behavior, then you have to convert all of that stuff to double, or you have to make sure that one of the operands is double. If I take an integer here and I divide it by a double, Java will automatically do the conversion. So this will convert the I value to, well, I had a value of 3, so it's going to convert it to 3.0. and then divide it by D, which is 2.0, and that will give 1.5. Okay, so you have to be aware of integer division. Okay. And what goes on there. You have operators similar to algebra. You have parentheses, and you can specify that to force expressions to be done in a certain order. And Java has shorthand notation. Instead of saying x is equal to x plus 1 or x is equal to x minus 1, you can say x plus plus. And that will be shorthand notation for x equals x plus 1. Arithmetic operator. Okay, to read from the keyboard, you can execute these commands in Java. So you have to create a variable. So what this line of code here is doing, this is the data type. This is my variable name. Okay. Now a variable name, you can give your variables any name you want. Okay. So I happen to call this one input, but input is not a special word in Java. That's just something that the programmer makes up. Okay. And this syntax here is the way that you create a scanner object. Okay, so a scanner is a special class in Java. Just like the system out class was used for printing things, scanner class can be used for reading in things from the keyboard. And this is the way you create it. Scanner input equals new scanner system in. Okay. So as the course goes on, we'll explain more about what all these things mean. But for right now, just to get started, when you have to read something in, you use this line of code there. If you want to read an integer, then you use the variable that refers to your keyboard input. You say input next int. Okay. The person can type something, and that will be converted into an integer, and it will be assigned to the variable j. If you want to read a double, so something that has a decimal point in it, then you can say input.nextDouble, and that will convert it into and put it into a variable r. If you just want to read a line and read it as a string, so you declare a variable. So this is a variable name, okay, and its type, it's string. This is the data type over here. And this will read whatever you type on the keyboard and store it as a string in the variable line. All right, to do certain math functions like square root, Java provides a class called math. So if you want to take the square root of a number, you say math.sqrt. So I could either do it this way, or I could declare a variable, double, r is equal to 16.0. And then I could say double, say x is equal to math.square root of r. Okay. So what would the value of x be after that? So here is, I have two variables, an r variable and an x variable. R has 16.0. After doing the square root function, x would have the value 4.0. Java doesn't have any way of doing exponents. So if you have to take 5 to the 3 power, Java has a method for doing that. So 5 to the 3rd would be written like this, math.pow 5.0 comma 3.0, and that would give you 125. And if you need the value of pi, Java has a special variable to do that called math.capital P capital I, pi. All right, there's one more thing I'm going to cover tonight, And I had hoped that we could get into the lab, but things always go slow on the first day of class. So we will get started on the lab, I guess, tomorrow night. So the last thing is random numbers. Okay. Random numbers are good when you are, first of all, it's good for playing games. We have to simulate rolling of dice or drawing cards or things like that. Also, if you're simulating something, a lot of times in simulations, you may be simulating cars driving down a highway, and you have to simulate various random numbers like, well, how many cars are on the highway at any particular time, or how fast are the cars going. Okay, so they're used a lot in games, and they're used a lot in simulations. So the way you can create a random number in Java is, again, you have to create something called a random number generator. And the way you do that is, again, this is the variable. So this is the variable name, generator. The type of the variable, Java has a class called random. And that will generate random numbers for us. So what we're doing here is we're declaring a variable called generator. It's of type random, and we're creating a random number generator. And to actually generate the number, then we call the next int method, next int method on the generator, and that gives us back a number that we're going to put into the integer. Now, if I give it a parameter of 6 here, what that's going to do is that's going to generate a number from 0 to 5. 0 to 5. So the parameter 6 says generate 1 out of 6. Generate a random number from 0 to 5. 6 different random numbers. 0, 1, 2, 3, 4, or 5. Okay. If I actually want to simulate, say, a dice, dice don't go from 0 to 5. They go from 1 to 6. So what I can do is I can just add 1 to it. So now my variable, the value of my variable goes from 1 to 6. Okay, so if I had to do something to simulate throwing of a single die, I could do that in this line of code in Java. Okay. Create the random number generator, generate a random integer from 0 to 5, add 1 to it. If I wanted to simulate a card drawn at random from a deck of cards, since there's 52 cards in the deck, I would say generator next int 52, and that would give me a value from 0 to 51. Okay? And if I wanted to get whether it was a heart or spades or diamonds or clubs, I could divide by 13. Now this is integer division here. This is integer division. So the result is either going to be 0, 1, 2, or 3. Okay, and I could interpret, say, 0 could be hearts, 1 could be diamonds, or I could come up with some scheme for doing that. Okay. And if I wanted to get the value of the card, I could make use of the remainder operation. Okay. Divide by 13, take the remainder, and add 1. And that would give me a number in that range there. So I can use the random number generator to simulate dice or simulate a card. We'll make use of all this stuff later on in the course. Okay, so I think I'm going to stop there tonight. And what we're going to do tomorrow then is we're going to take the stuff that we went over today about variables, data types, assignment statements, print statements, how to read things from the keyboard, how to generate random numbers, and we're going to put these things together and start writing some more complicated programs. So your homework for tonight is, if you haven't already gotten a copy of the book, is to get a copy. And if you've already got a copy of the book, then you have your homework done. Okay. So, and you may want to start taking a look through chapter 2. Okay. And take a look at the questions at the end of chapter 2. If you have the 5th edition of the book, it would be on page 100. So it's the multiple choice true-false questions. And there's about 20 questions, 21 questions there. And see how many based on what we talked about today, and skim through the chapter and see how many of those questions you can answer. All right. And then I will see you back here tomorrow at 6 o'clock, and hopefully our networking and things. Oh yes, thank you for reminding me. 2 things. So 1, take your name cards with you and don't lose them. Bring them back tomorrow. And the pieces of paper that you filled out that tell me something about yourself, please, you can just leave those up here, and that will be fine. Thank you very much.